All right, let's go ahead and talk about dilutions, a very, very important part of chemistry and something that is used quite frequently. And so, to save time and space in laboratories and in chemistry classrooms, solutions are often purchased at a higher concentration, and we'll talk about why they're purchased at a higher concentration, and they're stored at that higher concentration, and these are called stock solutions. So if you were to go into the chemistry stockroom and look at solutions, we have very concentrated solutions in there. And that's the way that they're ordered. And so what you can do with those concentrated solutions is you can add some water. So water is added to achieve the desired molarity of a particular solution. So for example, let's say we have hydrochloric acid. We'll talk about that later. But in the stockroom, the hydrochloric acid is, let's say, 12 molar. And if we wanted to have a 2 molar solution, we can pour out some of that acid and add it to water. And then what this is called, this is known as dilution. So again, what you're doing is you're diluting the concentrated solution until you get to the concentration that you wanted. Now when you dilute with water, diluting with water, does not alter the number of moles of solute present. And the perfect example that I like to give is my wife. She loves chocolate milk, and so we get Nesquik, and she wants me to make her some chocolate milk. Now, when I make chocolate milk, I put a good 5 scoops of chocolate powder inside of the milk, but she doesn't like 5 scoops. She likes 2 scoops. And so what she does is she takes the solution that I made and she adds milk to it. So if I gave her some milk that had 5 scoops of powder in there, and she adds more milk to dilute the powder, is there fewer scoops of powder in there? And the answer is no. There's still 5 scoops in there. It's just now that there's more milk. And so the key here is that when you're adding water to a solution, the number of moles in there does not change. So if you start off with 2 moles in the solution and you add a bunch of water, there's still 2 moles in there. Now the concentration changes. It's less concentrated because those 2 moles are now, within a larger volume, but there's still 2 moles. Something to keep in mind is when you are diluting an acid, you always add the acid to the water. You never add the water to the acid, and the reason why is because if you add water to acid, what ends up happening is you form this sort of extremely concentrated solution of acid, and this can actually cause splashing to occur because of the exothermic reaction of that. And so we'll talk about that later, but essentially it produces a lot of heat, and it can splash around a little bit and splash some of that concentrated acid all over. But when you add the acid to the water, that does not happen. So you always want to add acid to water instead of vice versa. So when diluting solutions, it's important to remember that the number of moles, very important, does not change. All right, so again, when you're adding water to a container, the moles inside of that does not change. The concentration changes, kind of like what I said. If you put 5 scoops inside of the milk and you add more milk, there's still 5 scoops in there. The concentration of it is not so chocolatey, but it's still got 5 scoops in there. And we're going to use this equation here to help us with solving some of these problems. We know that if we start with a certain volume, and if we start with a certain molarity, okay, and let's say that we change the volume to something else, we can calculate what the new molarity is going to be. And so this is actually very similar to the combined gas law from last unit. So let's go ahead and do some practice problems. All right, so keep in mind we are going to use this here. M1V1 equals M2V2, okay? And so Now, there's something that's really important about these problems, and I'm going to point that out here in a moment. But we're starting with a certain volume, and we have a certain molarity. Now, what happens is we dilute the solution with 300 milliliters of water, and what that means is we add 300 milliliters of water. And what I want to say is this is not M2. Oh, I'm sorry, V2. This is not V2. And this is really important to think about, because what we're doing is we're starting with 600 milliliters and then we're adding 300 milliliters. And so what is V2 going to be? Well, again, we start with 600, we add 300, so V2, volume 2, is going to end up being 900, because again, we have the 600, we add the 300, and now we have 900. And the question is, what is the new concentration? And whenever you see the word concentration, you want to think molarity. So let's go ahead and plug this in. So M1 is 3, V1 is 600. Now M2 is what we are looking for, and V2 is 900. Now, before we even solve this, is the new molarity going to be a larger molarity or a smaller molarity? Well, again, we're adding water. You have the same number of moles in there, but we're adding more water, meaning that it's going to be less concentrated because the same moles are inside a larger volume. And so when you type this in the calculator, your new molarity is equal to, so M2, the new one, is going to be a 2 molar solution, and this is the answer. And we're happy because these are easy problems. They're not that bad. All right, let's go ahead and do the next one now. It says a 50 milliliters of pure water is added to 300 milliliters of a 4 molar solution. What is the concentration after you add that to the water? Well, again, this is going to be V1, this is going to be M1, and V2 is going to be the 300 plus we're adding 50 milliliters. And so you end up with 350. And you just plug this in. So it's going to be 300 times 4 is equal to V2, which is 350, times M2. And then you just plug that in your calculator, you solve for M2, basic algebra, and what you end up with is M2, the new molarity, is going to be 3 point, and I know the sig figs are going to be bad on this. We're just going to do 3 sig figs on this, even though that doesn't, should be 1 sig fig, but the sig figs are messed up here. Molar solution. So the new molarity is 3.43 molar solution. And this guy is happy. All right. Now look at this next problem. This next problem is a little different because it's asking how many milliliters of stock solution would you need to prepare 100 milliliters of this molar solution. So our stock solution, again, when we go into the chemistry stock room, we have larger concentrated solutions. But if we're doing some sort of lab where we need a 0.5 molar solution, the question is, how much of this do we need? All right, how much of this do we need? And so again, this isn't M1, V1. This is going to be V1, this is M1, and then this is M2. And what we're looking for is V2, and that's what that is. Now, it's going to be 100 milliliters multiplied by 0.150. And actually, I want to pause real quick. Notice how this is milliliters. It does not matter if it's milliliters or liters. All that matters is that if you're starting with milliliters, you'll end with milliliters. Now, if the problem was asking for liters, you would then do this. You would end with milliliters and convert it to liters. And then, then M2 is 2, and we're looking for V2. And all you got to do is type that in your calculator. It'd be 100 times 0.15 divided by 2. And V2, the answer is 7.5 milliliters. Now, I want to go ahead and I want to talk about, this is the answer to this problem, but I want to talk about like really what are we doing here? So, if we have a stock solution, and it's a 2 molar solution, what we would need to do is measure out 7.5 milliliters of that solution. Now, what would we then need to do to make that solution become this 100 milliliter solution of 0.15 molar concentration? What we would then need to do is we would need to add enough water to get 100 milliliters. And so what I'm going to do right now is not part of this problem. This problem's not asking that, but I'm just taking it a step further. The answer to this problem is this, but I'm taking it a step further and saying, well, what would we need to do with this 7.5 milliliters? Well, if you take a look, if we want it to be 100 milliliters and it's 7.5 milliliters, all you have to do is subtract it, and you'll see that you would need to add this many milliliters of water to this solution, to 7.5 milliliters of the original stock solution to achieve the new solution. And so we'll do some more practice problems of this in class. But that's all there is to dilution problems. They're really straightforward. What I'll say is this third one, I really want you to think about this third one a little bit because that's the one that trips people up. But again, the whole idea is if we want to make this lower concentrated solution, we just need to figure out how many milliliters to measure out of the concentrated solution, and then we add enough water to it to make it become the volume that we are wanting. So that's all there is to it. Make sure you come with questions. Have a great day.